What I'm about to tell you might sound insane. It is insane. Or is it? Wolves fighting climate change might just be one of the most genius arguments I've heard in years. Here's why. Sometime in the second part of the last millennium, there very briefly existed an endling of the British Isles wolf. You might not be familiar with the term endling. It's actually a relatively new word for a relatively new problem, the last known surviving member of a species. And one with whose death all of the millennia of genetic refinement, adaptations and trade-offs that came to define what that animal is are lost forever. Some of these last animals are well known, like Martha the passenger-pigeon, or Benjamin the thylacine, who was in fact neither an endling nor called Benjamin. But in the case of the last British Isles wolf, we know almost nothing. In fact, we know exactly nothing, because when the last surviving members of the species were eradicated from Ireland in the 1760s or sometime around then, nobody would have had any reason to think that this nuisance animal would ever be desirable to have around, much less to document or study. And so it wasn't until 100 years had passed that the first serious publication on wolves in Britain was penned. By that time, the idea of wolves roaming the forests and mountains of the island was little more than a fairy tale removed from living memory and imbued with all the romanticism and prejudice of fiction, and in the end people forgot much of the hatred that had led to its disappearance in the first place. Which brings us to the topic for this video. In the 1960s, word started to spread that the wolves should return. In fact, the idea gained enough traction that by 2009, researchers at the Oregon State University proposed an experiment to release wolves in the Scottish Highlands, one of the more remote areas in the UK. They hoped that doing so might help the degraded ecosystem in the same way that wolves had helped repair Yellowstones, by reducing overgrazing. But while there are a good number of captive packs today, and a number of escapes from captivity over the years, Britain still doesn't have any wild wolves, because the proposal just couldn't quite get the government backing it required. Even when a millionaire local landowner threw their weight behind the movement and pushed for a large-scale fenced-in experiment, it wasn't enough to overcome the political hurdles. If you ask an AI to summarise the topic, you might be directed to this 2015 article by the European Wildlife Society, which confirms the release of 6 animals at an undisclosed location. But this article was published on April 1st, and well, believing it might be a bit foolish. Despite what many people think, wolves were never reintroduced in any part of the UK. The reason for this is simple. It's cost versus benefit. Bringing the wolf back to Scotland wouldn't be cheap or easy. And changing the browsing habits of deer isn't enough to justify all of that expense. Politically, it's just not been beneficial or really viable at all. But what if someone proved it was? That's kind of the holy grail of the people who campaign on behalf of the species' return, and shockingly, someone might have gone and discovered it. In February this year, the British Ecological Society published an unlikely new report claiming that introducing wolves to the Scottish Highlands could remove 1 million tonnes of carbon dioxide from the atmosphere every year. You're probably wondering how exactly wolves take the carbon out of the air, and the answer is they don't, because wolves don't photosynthesize. Trees, however, do. Scotland and the UK as a whole don't have many trees. Only around 13.5% tree cover remains, and only 1.2% of that is natural. Now, trees and wolves have an excellent relationship. Wolves like to hunt deer, and consequently the deer have less time to eat young trees. This phenomenon is known as the landscape of fear, something we discussed in the last video. So more wolves means more trees, right? And More trees means more carbon removal, which is always appreciated. That's what this paper set out to prove, by simulating the changes in tree cover that could be expected from declining deer numbers following a large-scale wolf reintroduction effort. Still with me? Okay, let's see what they predicted. Estimating future deer populations relied on using something called a Markov population model. This is a common mathematical description of a population's projected state based on its current one. Some of you might know that I'm not a biologist and have never had to use any population modelling, so yeah, I'm sure it was fine. I mean, they have plenty of data to extrapolate from. Scotland have been keeping a close eye on their deer numbers for the last half a century because, well, it's out of control. There's almost 1 million of them. That's almost 1 deer for every 5 Scots. When it came to estimating the numbers of wolves, however, things were a little less straightforward. Since Scotland doesn't have any, the researchers had to use other populations as a proxy to make their best guess. Since the number of animals in this case would be much lower than that of the deer, they used an agent-based population model instead, which is a lot more complex than the one they used for the deer. An agent-based model simulates the life of each individual instead of just a broad equation applied to all of the animals. This means that the life of each wolf in a pack is considered, including things like their age, sex, location, and position in a family unit. Now, wolf pack dynamics are notoriously complex, so even events such as dispersal following the death of both alphas was Wait, what? We don't call them alphas. They are breeding pairs. Alpha dominance is only observed in captivity because the structure is unnatural and... never mind. It's just a word. It's just a word. I'm sure they will set accurate parameters for behaviour. Alpha individuals are assumed not to disperse. If both alpha individuals died, all remaining members of the pack dispersed. If only one dominant individual was alive, the pack continued to occupy their territory but did not breed until a dispersing adult joined the pack. Dispersing wolves that were not successful in establishing a territory were assumed to die. We assume that dispersing wolves cannot join packs with an alpha pair. We assume that 30% of the dispersing wolves were not successful in occupying a territory when vacant territories were available. Okay, that's a lot of assumptions, and they're mostly reasonable for isolated packs. But, they forgot something. Wolves die. Like, a lot. There are entire essays that discuss the mortality rates, and in some populations, the most lethal thing for a wolf to encounter is another wolf. Seriously, not to mention the chances of injuries obtained whilst hunting, from extreme weather, disease, or human trapping, road crossings, and just random events that are part of living life as a wild carnivore. I think this study is going to be very optimistic in terms of survival rates. But enough of that, let's reintroduce some wolves and see how they fare. The study assumes, again, that each of Scotland's wildlands areas, those are the coloured regions on the map, will receive 3 packs of wolves each. Each of these areas are between 2100 and 4100 square kilometres, assuming a minimum of 600 for a wolf pack to function. I've seen the territories occupied by packs in the wild, and yeah, with high prey density and little to no human presence, I think this is feasible. And look, we can see there are areas of the country with less than or equal to 1 human per square kilometre. Oh, to be that 1 human in a square kilometre. Hooray! When we overlay these maps, we can see that the wolves have a good amount of space to roam about. What we don't want to forget is the road network though, so let's overlay that as well. Okay, well, we might sustain a bit of collateral, but they'll learn to stay away from cars. Oh, and land use as well. Oh. Okay, clearly there may be some complications here. Well, that will probably be mitigated by the study areas being completely fenced in. Oh. What do you mean freedom to roam Act 2003? There's plenty of hiking trails elsewhere. Use those instead. For comparison, the Colorado reintroduction zone originally saw 10 wolves introduced, That area is 60 by 120 miles, or 11,500 square kilometers. It's almost 3 times the size of the largest area in the study we're looking at. But let's assume it works, because this is all just a thought experiment. These population models are run with the assumption that the wolves behaved predictably, and those simulated wolves began eating the simulated deer. Where the deer populations decreased below 5 to 10 per square kilometre, forest regeneration began. When this happened, the researchers assumed that carbon sequestration began. Trees don't work like that. They can take a long time to store more carbon than they emit. But sure, let's say they do it straight away. They estimated the total amount of carbon sequestration that each wolf had led to, a sort of wolf carbon credit, I guess, and things are already in trouble because they found they might only be 13 to 14 wolves per 1,000 square kilometres, so they then suggest this might be higher if the wolves preyed on species other than deer. I think this might impede on the carbon credits generated per wolf, but this is all wild speculation now, so we arrive at the conclusion somehow that the average carbon value per wolf is, are you ready? £150,000, or $200,000. This works out at each wolf indirectly helping capture 6,080 tonnes of CO2 per year, a total of 114,000 tonnes over 100 years. This, I guess, sort of helps the Scottish Government's plans to capture 5 million tonnes per year, so yay! I mean, we're not considering the carbon cost of transporting all these wolves from around the world, or building the fences all around Scotland, diverting road networks around these fences, relocating settlements. You know, those kinds of massively expensive logistical undertakings. Maybe they could transport the wolves through the Eurotunnel on Cybertrucks to save some gas. Perhaps they could even source the wolves from Spain, because the Spanish government are shooting wolves to eliminate the food waste they leave by not fully consuming carcasses. I think I stopped taking this video seriously at some point during script writing. It was at that moment I realised this paper is genius, because Scotland has nothing to do with its intended application. Much of Europe has seen a political shift in recent years, as I'm sure you know, and with it the delisting of the grey wolf. This means it's becoming far easier to hunt them in many countries, and opposition to this is unlikely to sway local governments anymore by weak arguments of biodiversity safeguarding or ecological protection. What might grab their attention, though, is carbon capture, storage and utilisation. The European Commission's targets to become carbon neutral by 2050 still stand, but with a loophole. Only net emissions have to be zero, which means that with enough carbon capture in place, they can continue burning fossil fuels. This means that wolves could suddenly become a factor in the race to net zero, since each one that is destroyed comes at the cost of reducing emissions at the source instead. Europe's wolves have lost their intrinsic value as an apex predator, but they've been given importance in a new landscape, the abstract political wasteland of statistics, interest groups and legal bindings that reduce them to nothing more than numbers in the fight to offset carbon emissions. But if that's what it takes to help save them from regional extinction, then